Hey guys, let's talk about 4.1 and 4.2, properties of exponents. Exponents represent repeated multiplication, just like multiplication represents repeated addition. For example, if you had to add 4 10 times, you wouldn't do 4 plus 4 plus 4 10 times, you do 4 times 10. Similarly, if you have to multiply 4 10 times, you aren't going to type 4 times 4 times 4 times 4, etc. Anywhere, you're going to do 4 raised to the 10th power. But as a result, exponents have rules. First being product rule, and that's generally when you multiply with the same base, you add the exponents. Think about x squared is 2 x's, x cubed is 3 x's multiplied together. That means if you multiply both of those together, that's a total of 5 x's multiplied together, which is x to the 5th. Now how could you have done that looking at the exponents? 2 plus 3 equals 5. So let's just look at this. X cubed times x. Remember, if you don't see an exponent, it's really to the first power. Add these, that's x to the 4th. Now, if there's a coefficient in front, you just do the normal operation for those. So 3x squared times 5x cubed, 3 times 5 is 15. But then for your exponents, you do add 2 plus 3 to get 15x to the 5th. Again, negative 3z to the 4th times 2z squared. Negative 3 times 2 is negative 6. 4 plus 2 for the exponent, though, is 6. Now, if you've got 3 things you're multiplying together, you just do 2 at a time, get an answer, and then multiply by the other one. So 4 times negative 2 is negative 8. Y cubed times y squared. You add the exponents. 3 plus 2 is 5. And from there, I can combine it with the 10, y to the 5th. Negative 8 times 10 is negative 80. Y to the 5th times y to the 5th. Add 5 plus 5, get y to the 10th. Now, is there a precedent for this? Well, think about, what if you had 4 times 2 times 3, for example? Are you going to try to multiply all those at once, or are you going to do 4 times 2 and get 8, and then multiply by 3? Most likely that. So the point of this is that the same rules apply for our normal numbers. If there are multiple variables, you just deal with them separately. Negative 3a to the 4th b times 7a squared b cubed. Negative 3 times 7 is negative 21. A to the 4th times a squared is a to the 6th. Now this b is b to the 1st. B to the 1st times b cubed is b to the 4th. And if there's a 0, you're adding 0 to something. Remember, anything to the 0th power is the equivalent of not being there at all. So just keep that in mind, and I will let you do 6 on your own. Now, the next rule after product rule is quotient rule. So when you're multiplying with the same base, you add exponents. If you are dividing with the same base, you subtract exponents by the same argument. So y to the 7th divided by y cubed, 7 minus 3 is y to the 4th. Again, you divide your coefficients like normal. 65 divided by 13 is 5. Z to the 7th divided by z to the 6th. You subtract 7 minus 6 to get z. So the whole thing is 5z. Negative 48x cubed y to the 5th divided by negative 12x to the 1st y to the 5th. Negative divided by negative is positive. 48 divided by 12 is 4. X cubed divided by x is x squared. Y to the 5th divided by y to the 5th, 5 minus 5 is 0. So this becomes y to the 0th power. Now, y to the 0th power, just like anything else to the 0th power, this is a 1. So we can also just write this 4x squared times 1, but that is just 4x squared. So you don't need to the 0th power in there because it becomes 1 regardless of what the variable is. But if it helps you, go ahead and write it in. I'm not going to count it wrong if you put it in there. Okay, and then we'll go ahead and do the 3 variable one here. Negative 42 divided by 3 is negative 14. A to the 11th divided by a cubed. 11 minus 3 is 8. B to the 9th divided by b to the 5th. 9 minus 5 is 4. C to the 27th divided by c to the 7th is c to the 20th. Now, you notice all of these, we had a larger exponent, or the same size, in the numerator as the denominator. That doesn't always happen. So we have to have a method for dealing with negative exponents. So let's work on the negative exponents. Now, a negative exponent, let's think about x to the negative fourth. We know that if we multiply by x to the positive fourth, we will get x to the 0th by adding negative 4 and 4. So if we look at x to the negative fourth divided by 1, and we multiply the numerator and the denominator by x to the fourth, we get x to the 0th up top, but we're left with an x to the fourth in the denominator. So what happens here? That means we turned a negative 4 exponent for x in the numerator into a positive 4 in the denominator, and that's generally true for negative exponents. You may switch them to the other part of the fraction, from numerator to denominator, or denominator to numerator, and change the sign of the number. So when it says divide the monomials, we write using positive exponents only. Y to the 7th divided by y to the 11th. If you did your normal subtraction, and did 7 minus 11, you would notice you get y to the negative fourth. However, this is y to the negative fourth, we can flip this to the denominator, this is in the numerator, y to the positive fourth. Now this leads some people to a second option. If you don't want to deal with flipping, because you find that a little bit confusing, you can instead look at where the larger number is, see 11 is in the denominator, and do that number minus the bigger one, or minus the smaller one. 11 minus 7 is 4. You just need to make sure to leave it wherever the larger number is. So that's two options. So 7, let's look at 6. 75 divided by 25 is 3. Now where's the larger power of y? In the denominator. So take 13 minus 4, because it's in the denominator, that's 9. Because the larger one's in the denominator, you have to leave y in the denominator. If you do it the other way, you'll get 3y to the negative 9th, and then have to flip the y to the denominator. Now it should be noted, when the variable goes down, the exponent switches, but any coefficient stays wherever it is. So let's look at, say, number 7, and we'll skip number 8. 60 divided by negative 10 is negative 6. J to the 6th divided by j to the 3rd, the bigger one's on the numerator, so all we have to do is subtract. Now looking at k to the 9th, 9 minus 14 is k to the negative 5th. If we subtract numerator minus denominator. But we can't leave negative exponents, so this whole thing has a negative exponent and it needs to go down below. But the other two are fine. A negative coefficient can stay in the numerator, only negative exponents move. So we need to fix this to negative 6j cubed divided by k to the positive 5th. Okay. Now, this is the first time on number 9 that we have the denominator is larger for the coefficient. 21 divided by negative 147. 147 divided by 21 is exactly 7, so this can be reduced to 1 and 7. I'm going to bring the negative out front. That means I need to leave the 7 in the denominator because the denominator had a bigger value when we're dividing it. It's a fraction. 9 minus negative 2. It's really 9 plus 2, so that means we have r to the 11th. 4 minus 11 is negative 7. That means we would have s to the negative 7th in the numerator. But again, we can't leave negative exponents there, so it goes down to join the 7. So we end up with r to the 11th over 7s to the 7th. We'll quickly do 10. Negative 18 divided by 6 is negative 3. 5 minus negative 2 for our a exponents is 7. B, negative 6 minus 5 is negative 11. C to the 4th divided by c to the 4th is c to the 0th, because 4 minus 4 is 0. Now remember, anything with a 0, it's like it's gone as an exponent. But we do need b to move, so this is negative 3a to the 7th over b to the positive 11th. And we will continue 4.1 and 4.2 in the next video.